Tonight's video lesson is on naming ionic compounds. This is video lesson 2.7 as part of our forensic science unit, and you are to watch this video for class on Monday. My objective for you tonight in this lesson is that you'll be able to name ionic compounds involving elements from the periodic table. You'll be able to name ionic compounds involving transition metals, and that you would be able to name ionic compounds involving polyatomic ions. Before we get into naming ionic compounds, I just want to review a couple things real quick. Ionic compounds have at least one metal, the cation, and one nonmetal, or the anion. The charges for an ionic compound always balance out to zero when the chemical formula is written correctly. So how do we go about naming an ionic compound? To begin with, when naming an ionic compound, we're going to create a little chart here that's going to help us. And so the cation, there's a couple things you can do. If it comes from the periodic table, the name of element is all you need. If it is one of the transition metals, or the chart from page 255, you need to look at page 255 and include the element name, with Roman numerals. For the anion part, if the anion is an element from the periodic table, you're going to change the ending to IDE. If the anion is a polyatomic ion, so it has more than one element involved with it, use the chart from page 257. Another way to look at this here is for the cation. Periodic table, copy the name. Transition metal, page 255, and include Roman numerals. For anions, if it comes from the periodic table, change ending to IDE. Alright, so if it's carbon, it would become carbide. If it's oxygen, it becomes oxide. If it's sulfur, it becomes sulfide. If it's polyatomic, copy the name. On the next slide here, we're going to go through a couple of examples for this. Let's say, for example, I take NaCl. And so my cation is Na+1, and my anion is Cl-1. So for the cation part of the name here, I'm going to first look and see if this is one of my transition metals. And so sodium is not one of the transition metals. It's only going to have one charge. So then I just need to copy down the name from the periodic table. And so the sodium ion just gets written as sodium. Then I go and look at my anion. Cl is just one atom, so it's not a polyatomic ion. And so I'm going to go to the periodic table and I'll notice that Cl is the element symbol for chlorine. When I go to write it though, instead of writing chlorine, I'm going to change the ending to chloride. If we do MgO, my cation is equal to Mg plus 2. My anion equals O minus 2. So the cation, again, magnesium is not a transition metal, so it's just written as magnesium. Oxygen comes directly from the periodic table. It's not a polyatomic ion, so I'm going to change the ending to an IDE, and it just becomes oxide. What if I have a transition metal involved with this, though? And so if I have PbO2, now lead is my cation, right? And if you looked at this, we don't necessarily know what the charge of the lead ion is yet, but we can determine it from our oxygen anion, because oxygen is always going to be a -2. And so this is saying that I have 2 oxygen atoms necessary to balance out my 1 atom of lead. And so 2 times -2 is going to be a -4, so lead has to be a +4. And so this is going to be Pb plus 4. Now lead can have more than one charge, and so if you don't include the Roman numerals when you write the name, how would you know which lead you're dealing with? PbO is a very different compound from PbO2. And so I would need to make sure I include the charge of lead, and in this case it's lead 4. And our oxygen atom is not a polyatomic ion, so we're just going to change the ending to an IDE, and it's just going to become lead 4 oxide. If I were to have Cu2S, again, we don't know the charge of the copper yet, but we do know the charge of the sulfur, and sulfur has a -2 charge. And so from that I can see that I need 2 copper atoms to balance out 1 sulfur atom. So this must mean that copper has to have a +1 charge, because 2 times 1, that's going to give me 2, minus the 2 from sulfur, and that's going to balance out around to 0. So I'm going to write this as copper 1 sulfide. For our last set of examples here, we're going to look at a polyatomic ion. And so if I gave you Lip3O4 here. In this case, we know what lithium's charge is going to be, and lithium always has a charge of +1. And for phosphate, if you notice, it's got more than one atom involved, or more than one element involved with it. We've got PO4, so it has to be a polyatomic ion. So I'm going to go to that chart, and I'm going to see that PO4 with a -3 charge is actually phosphate. So for my cation, lithium only has 1 charge, so I write just lithium. And then PO4 with a -3 charge is always phosphate, so it's just lithium phosphate. let's take a look at this last one here. Alright, now if you look at your chart, is iron one of my transition metals? And in this case, iron is. It could be a +2 or it could be a +3, so I don't know the charge of that yet. But then I've got, in parentheses, Cn, and I've got 3 of those. And Cn is a polyatomic ion because it's got more than one element involved. And we know that it's cyanide. And cyanide has a -1 charge. And I can get that information from page 257. And so if each cyanide has a -1 charge and I have 3 of those, that means that I have to balance out a -3 charge. And so that must mean that iron is a +3. So if I write out the name here, I'm going to write it as iron 3 cyanate. Okay. On Monday when you come in, we're going to finish analyzing the data from our lab that we did on Friday. And part of it's going to ask you to take the chemical formulas that you determined for the products from the reactions, and we're going to come up with the names for those reactions. So make sure you have your data tables with you, and you're ready to go on Monday, and enjoy the rest of your weekend.